Class 9, Subject Chemistry, Chapter 1, Matter in Our Surroundings, Module 4. Objectives. At the end of this session, you will be able to explain how pressure affects the three states of matter, define evaporation, list the factors affecting evaporation, and explain the cooling effect of evaporation. Effect of pressure on gases. The physical state of matter can also be changed by changing the pressure. For example, gases can be changed into liquids by increasing the pressure, accompanied by lowering of temperature. And some solids, like solid carbon dioxide, can change into gases on decreasing the pressure. Pressure is a force acting upon an object. Let's take a syringe filled with air. For our experiment, we will seal the tip of the needle. If we push the plunger, it will move only up to a certain point, because when we push the plunger down, the pressure inside the syringe will increase as the molecules, that is particles, move closer to each other. At a certain point, the molecules cannot move any closer, meaning we cannot push the plunger any further. So we now know that gas can be compressed with an increase in pressure. Let's fill the syringe with water and seal the syringe tip. In this case, we can't push the plunger down as we did in the case of air. From this we can see that liquids are not affected by pressure. If we try to press the solid block of wood, we cannot compress it. We can see that effect of pressure on solids is negligible. Pressure also affects the change in states of matter. Under normal atmospheric pressure, water boils at 100 degrees Celsius. However, if we were to boil water in places of lower atmospheric pressure, such as the top of a mountain, it will boil much more quickly at a temperature lower than 100 degrees Celsius. Under high pressures, such as inside a pressure cooker, water will boil at a temperature higher than 100 degrees Celsius. When you use an air freshener spray, you may have noticed that the spray coming out of the nozzle is not at room temperature. It's actually several degrees cooler. Inside the container, the gas is under a high pressure. As it comes out, the pressure will drop. And as the pressure decreases, the temperature of the gas will also drop. By increasing the pressure, carbon dioxide can be changed to solid. Solid carbon dioxide is known as dry ice. By increasing the pressure and decreasing the temperature, air can also be liquefied. The pressure of air particles present in the atmosphere is called atmospheric pressure. The different units of pressure are Pascal, bar, and torr. Evaporation. The process of a liquid changing into vapor or gas at any temperature below its boiling point is called evaporation. The process of evaporation can be explained as follows. Some particles in a liquid always have more kinetic energy than others. So even when a liquid is well below its boiling point, some of its particles have enough energy to break the forces of attraction between the particles and escape from the surface of the liquid in the form of vapor or gas. Now let's see what are the factors affecting evaporation. The evaporation of a liquid depends mainly on the following factors: temperature, surface area, humidity, and wind speed. Increase in temperature increases the rate of evaporation. With the increase of temperature, more number of particles get enough kinetic energy to go into vapor state. Increase in surface area increases evaporation. Evaporation is a surface phenomena. If the surface area is increased, the rate of evaporation increases. For example, while putting clothes for drying up, we spread them out. Increase in humidity decreases the rate of evaporation. Humidity is the amount of water vapor present in air. The air around us cannot hold more than a definite amount of water vapor at a given temperature. If the amount of water in air is already high, the rate of evaporation decreases. Increase in wind speed increases the rate of evaporation. When the speed of wind increases, the particles of water vapor move away with the wind, decreasing the amount of water vapor in the surroundings. This increases the rate of evaporation of water. The washed wet clothes dry more quickly on a windy day because evaporation is faster due to the high speed of the wind. Evaporation causes cooling. You have already studied that whenever a liquid evaporates, it must be supplied the latent heat of vaporization. The cooling caused by evaporation is based on the fact that when a liquid evaporates, it draws or takes the latent heat of vaporization from anything which it touches. For example, when you pour some acetone, that is nail polish remover, on your palm, the particles gain energy from your palm or surroundings and evaporate, causing the palm to feel cool. People sprinkle water on the roof or open ground because during evaporation water absorbs heat and makes the hot surface cool. During summer, we sweat more because during evaporation the sweat absorbs heat from our body, making the body cool. Wearing cotton clothes in summer keeps us cool because cotton absorbs sweat, and when the sweat evaporates, it absorbs heat from our body, making the body cool.